So, there we go. Lecture 38, Diluting Solutions. So what we need to use is the equation from the book. And we have Mi is the initial concentration, or the stock concentration, initial volume. So we take a volume of a stock solution, or the beginning solution, and then we have, that has to equal the concentration of that we end up with after dilution times the volume. And the reason is this is concentration, which is moles per liter, and the volume is in liters, or we can put it in liters, and we end up with moles. Well, we end up with moles on the other side too. So if we take, so by taking the concentration times the volume on each side, we just end up with the moles of the solute. It doesn't matter what the volume is. And you can see this if you take a liter of 1 molar HCl. Well, in a liter of 1 molar HCl, you have a mole of HCl. If you dump that into a pool that contains 100,000 liters of water, you still have that 1 mole of HCl. It's been diluted, but it's the same number of moles. So that's why we're allowed to use this, because we're by multiplying the concentration by the volume, we get rid of those the volume and the concentration. We're just left with moles, the amount, the actual count of molecules that are in the solution. So now, how would you prepare 155 mils of 0.15 molar NaOH from a stock solution that is 15 molar? Okay, so what you need to do is determine, what I like to do is list everything that we have. The initial concentration, that's the stock solution, that's 15 molar. The initial volume, that's what we have to figure out. What they're asking when they say, how do we prepare it? Say, well, what do you start with? And then you dilute it. Well, we don't know this. The final concentration is 0.15 molar. And the final volume they give is 155 mils. We might as well convert it over to liters right now. And actually, we'll see that in some cases that's not necessary, but it's a nice thing to do here. So we have the concentration. So now we put everything in. We have 15 molar times the volume. Doesn't need to be in parentheses, but and then the final concentration is 0.15 molar, and the final volume is 0.155 liters. Now, since we have the same same units of volume on each side, I could have left this as 155 mils. Our volume just would have come up to be mils. That doesn't say either way in the problem how we should do it. So I change it over to liters. So yeah, this, and then divide by 15 molar. See, the units of concentration cancel, and we end up with 0.00155 liters, or that's 1.55 mils. If we had left it in mils to begin with, we would have ended up with this answer. And this is probably the better answer than liters, because this is such a small number here. Converting over to units that make a little more sense for us is better. I can easily envision the 1.55 mils, because I've dealt with our graduated cylinders, our 10 mil graduated cylinders. I can picture that. 0.00155 liters, that's a little tougher. Okay, what is the final molarity 15 mils of 12 molar HCl after it is diluted to 4 liters. Okay, so what is our final molarity? Well, they've told us that we don't know that. Our final volume is 4 liters, and then our initial concentration is 12 molar. So a lot of this is just picking out the correct, or what's what, which one is which for these variables. So setting these variables to certain values, we just got to make sure that the big thing is that you group them correctly. If you name this MF and this as VF, and this is MIVI, it won't make a difference in the answer. You might misunderstand what your answer means if you pick the wrong variable, but as long as they're grouped together, you're going to end up with the same answer. So just make sure that the initial concentration and an initial volume go together. If I had put this as 4 liters and this as 15 mils, then we would have gotten the wrong answer. So just be careful with that. So now that we have everything, just set it up. We have 12 molar. Now, since we've been given both volumes, we need to have them in the same units of measure. When one of the volumes is missing, well, then we can just leave the other volume in liters or mils, and we'll come up with either liters or mils as our answer. But here, since they've both been given, we have to convert one or the other. So I'm going to convert 4 liters to milliliters, mils, I should say. And then we have, so this is 15 mils, 15 milliliters, and then we have MF, unknown, and then VF is 4,000 mils. I put it in scientific notation because we only have 3 significant figures. So solving for the concentration, the final concentration times 15 divided by 4,000. Then after we've diluted this from 15 mils, we've added in enough water to dilute it to 4,000 mils. We should end up with a concentration of 0.045. I'm going to do it one more time, but that seems reasonable. It should be a very small number because we've diluted this thing by, let's see, diluted it by 267 times. So since we diluted it by that much, it should really drop drastically. All right. And I'm probably going to have to change this marker. I have kind of bleeding through, but let's finish out this lecture. How many mils of 11 molar KCl is needed, or are needed, to create 718 mils of 0.110 molar KCl? Okay, so this is same kind of problem, but a little trickier. We got to be careful here. Let's just write out the expression again. So our initial on this side, our final on this side. Figure out what we have. We initially, how many mils? Okay, so what we don't know is the initial amount that we need to start with. And then the initial volume. Oh, actually, no, we know the initial concentration. That's known. The initial volume is unknown. The final concentration is known. That's what we're after. Our final volume is known. And I'm going to leave this in, since we only have one volume, I'm going to leave it in mils just so you can see that you do end up with mils as your volume. And that's what they're asking for anyway. So if you change this over to liters, your answer would be in liters, and then you'd have to convert back to mils. So might as well leave it alone. Okay, so put this in here. We have 11 molar. And we don't know this volume. Our concentration is 0.110 molar, and our volume is 718 mils. Solving for our volume, and that makes sense because we have 11 and we have 0.11, so it should be different by a factor of 100, and it is. Okay, and just double check. Make sure I didn't miss a decimal place here. Looks good. All right. How many mils of 11 molar KCl is needed to create 718 mils? And that is our answer. Okay. How many mils of water must be added to 20 mils of 2 molar HClO to dilute it to 0.35 molar? Okay, now this one is a little different. That's why I wanted to put this one in. I thought initially that this one up here was that kind of problem. Let me just verify. No. This one is, the reason it's important, it's a little tricky, but it's very important because this is how you dilute in the lab. Well, let's just go through it and see. So we have our initial, how many mils of water must be added to 20 mils So our initial volume is, to dilute it to, okay, so our initial volume is 20 mils, and our initial concentration is 2 molar. Our final concentration is 0.35 molar, and what is our final volume? Now, when we get done, once we find the final volume, we have one more step to do. This gets students, catches them all the time. It's not, I said it's tricky, but there's really no trick questions. It's just that you guess what's going to happen and you guess wrong because you didn't read fully into the problem. Because there's a lot of ways of doing these problems, and if you're going to do it one way, and the answer is actually found by a slightly different path, you're going to be wrong. So we got to be careful. So 2 times, that's just 40 divided by 0.3. Okay. So our final volume, since this is in mils, and let me actually do this out so you can see the units, how they end up. Molars cancel, we're left with mils, so we end up with 114 mils. And that's how our answer should be. We didn't change it to liters, and we didn't have to. You say, well, this is moles per liter. Shouldn't we change this to liters? No, the moles per liter cancel, so those units are gone. So if this was mils or gallons or cubic meters, any volume unit could be used here, and we'll end up with the same one for our answer. Now, this is our final volume. That's what we need to end up with. But we started with 20. And the question isn't, what is our final volume? The question is, how many mils of water do we need to add? So it's 114 mils minus 20 mils. And I'm going to do this out, even though I should be able to guess it. I guess wrong. That's our answer. And actually, so we have... Since we subtracted, we'd actually end up with just 94 mils for our answer. Keeping track of our significant figures, because this only goes out to the ones place, this goes out to the tenths, but we need to add 94 mils. That's the question. That's what the question was. So we start out, it's what we do in the lab. You have 20 mils of your 2 molar HCl, and you want to get it to 0.35 molar. And he's, well, if we diluted that with water to 0.35, we'd end up with 114 mils, but we started with 20. So how much water do we need to add? 94 mils. Now, if you've come across this kind of problem, there's a little catch to it, is that when we add water to something that already contains a solute, generally speaking, we would probably have to add more or sometimes less water to get to 114 mils. Usually you'd have to add more. That's okay. If you're aware of that solute actually interacts with the water and causes some changes in the volume, that's great. But normally it's less than a few percent, and it won't make any difference. So just saying that, in case you've come across that and you're saying, well, what about this? It's okay. Normally we consider the water to be additive, and that we don't have to worry about those fluctuations in volume. So what you do is you find out what your final volume should be. You take what you started with, subtract them, and that's how much water you need to add. So water needed to be added is 94. Whoops. That's it.